Alright, so for number one is flag blowing. This is a big one. Lots of people always get upset about this one, and this is one of the most favorite that the theorists use to back their argument that it actually is fake. I actually have a short little demonstration proving that the flag is actually not blowing in the wind. Alright, so here we have our lovely living room fan, and I'm going to turn this one on, the highest speed. This is going to be creating our artificial wind, so you can see it moving in the screen. And I'm going to be demonstrating my fleece blanket as the flag. And I'm using this because it's very easy to move, so we'll get the greatest effect even with the fan and not like a 5 mile per hour wind. So I'm going to hang it up, and you're going to see it blowing in the wind. Alright? That is blowing in the wind. I'm going to try and get a better effect. I'm not moving my hands. Alright? So that was blowing in the wind. Alright. Stopping the fan. I'm going to leave the blade right there so you can see it. Not moving. Alright, now what people don't realize is that since there's nothing in space to stop something from moving, because it is a vacuum, any little movement you do will not stop anything. Like, nothing can stop it. So any little ripple, any force going through an object will continue going through. This is so annoying. Alright, so as you can see, the flag is perfectly still. But as soon as I move this hand, my right hand, it will move a little bit. You see that? See the flag blowing in the wind? Look, I can make it blow in the wind. Look at that. Doesn't that look like it's blowing in the wind? Alright. Now, also people don't realize is there's actually two support beams in the flag that is holding it up. There was one going like this, and there was one going like that. This is to hold the flag up so it doesn't look like that in all the photos. So here we go, we have our flag. Now you're thinking, oh, well, there's two support beams, there's no way it can move. It actually can. What we're going to be doing is we're going to go over to our pot of water, and we're going to be doing some fluid dynamics with you. But first I'm going to show you. It still has all of this motion. You see that? It can still move. So let's go over to that pot of water and let's do some fluid dynamics. Alright, so now here's our pot of water. Now what I'm going to be doing is I'm going to be showing you that an actual natural made force, let's say wind for example, as it would be in the blowing of the flag, can actually be equal to the force that you create with your body. So now what I'm going to do is I'm going to blow air, of course, coming out of my lungs across the water, and you're going to see the water move. Alright? You saw the water move. Now what I'm going to do is I'm going to take my hand and I'm going to put it in the water, trying to create the same movement. As you can see, you saw the water move. Alright? So now, what would be the difference between, let's say, air moving across and you holding it? But first, what we have to do is we have to put our hand in the pot and blow across it. This would be for the astronauts holding the flag and the air blowing across it. Alright? You saw me moving it. Now I'm going to do the same thing, except I'm actually going to blow air across it. As you can see, there is no difference. This would actually completely take out the fact that there is air blowing across the flag. As you saw, both video clips are the exact same. Me moving the water with my hand and blowing, and me just moving the water. I'm not blowing, as you can see I'm talking. And now I'm going to blow air across the water and move it with my hand. As you can see, no difference whatsoever. Right. Alright, now for number 2. There is no crater where the lunar module lands, and there's no dust on the lunar module. For the first one, you basically have to take into account the actual weight difference and the actual force required. And for the second part, you need to take into account that there's no atmosphere. Alright, so now for the first part. The weight difference is 1/5, saying something on here is going to weigh 1/5 its actual weight up on the moon. So let's say if I have a 5-pound object on Earth, it's going to weigh only 1 pound on the moon. So there we have it. The engine only has to propel 1/5 its actual weight. Therefore, the engine can be 1/5 as small. Now, for that, everybody's like, why is there not such a big blast crater? Well, the engine on Earth is actually propelling that 5 pounds. That's what people are confused about. The crater, there's actually still a crater there, but it's only 1/5 as small. And since there's only 1/5 the weight, it can only do 1/5 the damage. So, there you have it. The crater is actually there. It's just like this, rather than like that. And now for the dust on the rocket, we're going to begin using fluid dynamics to simulate an atmosphere. So let's go over to our pile of water again, and let's do some fluid dynamics. Alright, so now we're going to be using the food dye as the dust. So here is our atmosphere, and the dust is going to be moving around, and this, now when it hits, it is going to simulate the actual dust being acted upon by the rocket engine. That is why it's going to move out of the way. So the force of it dropping is going to be the force by the rocket. So let's watch and see what happens. As you can see, it immediately immersed like that. Now, as you saw how fast it spread out, the water, or our atmosphere, actually stopped it from moving out, and it is actually now, instead of hitting the edges of the pan, it is just sitting there. Now, of the course of gravity, you can actually see it settling onto the ground. So as you can see, it's sort of just floating around, and the majority of it has actually rested on the bottom of the pan. Now, if we took out our atmosphere and we dropped our drop of water, it would continue to spread out, and it would actually never stay in there and then float down. It would actually spread. It would actually do something like this. It would hit the ground, and it would immerse, and it would continue to go at the same horizontal speed, because remember, there was nothing to slow it down. So it continued going in the horizontal speed until the force of gravity actually brought it to the ground. That is why there is no dust upon the actual lunar module itself, because any dust that was kicked up was immediately thrown out of the way and rested on the sides. Alright, now the throwing of objects. This is also in Newton's law. An object in motion will stay in motion until acted by an outside force. Now, with people with the feather and the hammer drop, you really can't, say that's fake, because, of course, if you drop a feather and you drop a hammer on Earth, they both hit the ground at different times because of surface area and air friction. So what I'm going to be doing is I'm going to be dropping some polyfill and my notebook. So here we have our polyfill. Here's the polyfill. And here's my notebook. And I want you to watch and see what happens. Alright, so now what I'm going to do is I'm going to throw my notebook up, and I'm going to try and get it to hit the ceiling, and then I'm going to try and throw the polyfill and try and get it to hit the ceiling. Again, this is with an atmosphere. As you saw, the notebook was extremely easy. Now, with about the same amount of force, I'm going to try and get the polyfill to hit the ceiling. As you saw, it's nearly impossible. You would have, even if I was to throw this and make this hit the ceiling, I would have to wind up and throw it as hard as I possibly could. Alright, so now about our number 4 item, which are no stars in any of the films. This is actually a pretty good excuse